This video is about how we're going to find the sum of an infinite geometric series. So remember, finite means it goes to a particular, or there's a specific set of numbers, all right? Maybe there's 6 terms, 8 terms, whatever the case may be. Infinite means it never ends. So how can we find the sum of a set of numbers when the set of numbers never ends? That's kind of a conundrum if you think about it, all right? So we're going to talk about that, and hopefully in this lesson you'll get a better understanding. What we also have to be able to do is demonstrate an understanding of what's called convergence and divergence, all right? So I want to read, I'll read to you guys, read along with me. It says, the terms of a geometric series grow rapidly when the common ratio, that's our R value, is greater than 1. Likewise, they diminish rapidly when the common ratio is between 0 and 1. In fact, they diminish so rapidly that an infinite geometric series can have a finite sum. It has a finite sum when that R value, that common ratio, is between 0 and 1. So when I have a geometric series that is infinite, all right, the biggest thing that I want to be able to do is check and see, what is my R value doing? If my R value, or the absolute value of R, because obviously to be greater than 0, you have to look at the positive. If the absolute value of R is less than 1, we can find its sum. And the way that we do that is we take a sub 1 divided by 1 minus R. First term divided by 1 minus the common ratio. If it's an infinite series, infinite geometric series, but the absolute value of R, or that common ratio, is greater than or equal to 1, you can't find it. It doesn't have a finite sum. All right? So when we have this R value, okay, that is less than 1, we are going to refer to this scenario as convergence. All right? It's approaching a particular value. And that value that it's approaching is what our sum is going to be. Okay? Now, if that R value, the absolute of R, is greater than or equal to 1, we're going to say that it diverges. All right? So it diverges, which means you can't find its sum. Okay? So the first thing we want to do here is let's just take a look and says, does it converge or diverge? When we are answering this question, we want to be able to defend what we say by explaining, well, the R value is this. For example, in the first one here, I see that the R value is 1/5. I know that the absolute of 1/5 is less than 1. So therefore, I can determine that this converges. In the second one, they give me the R value here, and I know that the absolute value of R here is going to be greater than or equal to 1. And because that absolute value of -4 is greater than or equal to 1, this diverges. Now again, just to remind you, if it converges, we're going to be able to find its sum. If it diverges, we can't. Okay? So what if they just give me a list of terms? Notice, first of all, that this is how I know that it's infinite. Do you see the ... at the end? They're telling me it's not ending. This pattern is going to continue, okay? Remember how we determine the R value. The R value is to take a term and divide it by its previous term. All right, so I took 1 divided by 3. You could have taken 1/3 divided by 1. You could have taken 1/9 divided by 1/3. No matter what you do, you're going to get an R value of 1/3. All right? Because 1/3 is less than 1, absolute value of it is less than 1, then we're going to say that this converges. Okay? Now, if you notice this pattern right here, the R value for this would be 12 divided by 4, or 3. Because this R value is greater than 1, we would say that this diverges. And if you notice, I didn't just write down converge or diverge. I defended it by saying this is what my R value is. Okay? So if it is infinite and it has an R value whose absolute value is less than 1, we can find the sum of the series. In this first one, I know that the absolute value of negative 1/3 is less than 1. This converges. When it converges, we can find its sum. And the sum, again, is a sub 1, which in this case would be 972, divided by 1 minus r. Now, r in this case is negative 1/3. So I'm going to clean this up a little bit here. This is really saying 972 and 1 minus negative 1/3 would really be 4/3. Now, you guys know me. The way that I like to think of this is I say, well, that's really 972 over 1 divided by 4 over 3. So I get a sum here. I'm going to use big C, little c. 3 times 972. That gives me 2916 over 1 times 4 is 4. And I'm going to go ahead and see if that divides out nicely. And it does. And I get a sum of 729. All right, take a look at the second one here. All right, the absolute value of R, the absolute value of negative 2, is that going to be less than 1? No, it's going to be greater than or equal to 1. This diverges. If it diverges, can't find it. All right, so how about this scenario now? All right, they're not telling me the R value, but I can find it. I know that R is going to be 80 over 160, which would simplify to 1/2. This converges. And because it converges, I can find its sum. The sum is going to be a sub 1, 160, over 1 minus R, and R in this case is 1/2. So this would be 160 over 1/2. 1 minus a half is a half. And I know that this sum would be 320. How do I know that so quickly? Dividing by 1/2 is the same as multiplying by 2. All right? So another scenario, the last scenario that we're going to look at here, is how do you determine the common ratio of an infinite geometric series? So because they give me this big S, this capital S, I know that this has to have an R value that is less than 1. I'm going to use the formula. Use the formula and say negative 40, my sum, is equal to a sub 1 divided by 1 minus R. Now, we have a couple of different ways that we can do this. Personally, I always like to just think of that first term as being over 1. And then I'm going to cross multiply to solve. So if I write this out as a cross product, it would be negative 40 times 1 minus R is equal to 1 times negative 20. All right. I've always found this to be the easiest way. It may take an extra step or two, but I think this is the easiest way to do it. I have negative 40 plus 40R is equal to negative 20. I'm going to add 40, so 40R is equal to 20. Divide both sides by 40. I get R is 20 over 40, which is 1/2. And that makes sense because I know that there was a sum able to be found in an infinite series. That means that the R value has to be less than 1. The absolute value of R has to be less than 1. Hope this helps. Let me know if you guys have any questions.